I am a translator, transforming text into creative discovery. Movement into animation, and direction into action. I am a healer, exploring the building blocks that make us unique. Modeling new threats before they happen. And searching for the cures to keep them at bay. I am a visionary, generating new medical miracles. And giving us a new perspective on our sun to keep us safe here on Earth. I am a navigator, discovering a unique moment in a sea of content.
We're announcing the next generation.
And the perfect setting for any story. I am a creator, building 3D experiences from snapshots and adding new levels of reality to our virtual selves. I am a helper, bringing brainstorms to life.
From different angles.
Sharing the wisdom of a million programmers. And turning ideas into virtual worlds.
Build Northern Forest.
I even helped write the script. Breathe life into the words and compose the melody. I am AI, brought to life by NVIDIA, deep learning, and brilliant minds everywhere.
Good morning. It's really great to be here with you. What you saw was an amazing use of AI and generative AI across so many different industries. What's happening is this explosion of use cases and technology that's come to play. We've been working for decades with all types of artificial intelligence, but most recently, of course, a new form has come into the forefront. But it's not just about text to text. I think that's what everyone's most familiar with. ChatGPT, you type something in, you get a great answer. May be right, may not be right, but again, it was trained on everything that's out there on the internet. But we're not just talking about text to text, but how do we leverage this technology from one data stream to another data stream? So it could be text to image. Type something using Stable Diffusion, you get an amazing picture based on some words. Or text to video, using Runway ML. Type in a description of a scene, and the AI will generate a video of that scene. We can do this in healthcare with DNA sequencing, with protein folding, drug discovery. There's so many ways to take one data stream in and another out. So in the automotive industry, we're really focused on bringing this earth-changing technology and enabling all of you in your different jobs, whether you're a designer, whether you're an engineer, whether you're a journalist, to be able to do your job better. AI is not going to replace the job, but it's going to be a tool, an agent, an assistant, a co-pilot to enable you to do much better work. Within the auto industry, then, there's so many different parts of bringing cars to market, from design to engineering, the factory, production, and of course what a lot of us are working on as well, which is automated and autonomous driving. AI, and now generative AI, is playing a huge role in this whole production process, even selling cars. what we can see is, let's take the first step, which is styling. Using generative AI, we can create new models. We can create a vision for the car. And instead of the designer having to go through and pore through the internet, try to come up with other ideas to do research on a particular brand, AI is going to help them with, it's been trained on different styles, it's been trained on different brand identities, and they can use that in the ideation process. Again, it's this assistant that lets them iterate on their models, try out different examples, really help them brainstorm and to be able to do it in real time. And then be able to essentially bring a lot of different options to their management and recreate a better workflow, ultimately resulting in cost savings, maybe a safer design, more energy efficient design as well. There's an amazing tool out there called Viscom. Artists can just sketch, and it takes that sketch and creates a 3D model and renders it instantly. And they can iterate and continue to try out different examples, different styles, different techniques. In this case, highlighting part of the model and giving it a prompt, make it a Ford, and it goes and it generates that, or change the kinds of materials, change the look and feel in an interactive way. So this is an amazing breakthrough for the design of these vehicles. More and more applications now are taking advantage of the technology. So it's not that there necessarily has to be a new CAD tool learned or a new design tool learned, but new features and functions are coming from the power of having GPUs in their workstation or GPUs in the cloud to enable this. Here you see you do some minor sketches, make it the front end of a Porsche, and it renders it now as the headlights of a Porsche would be. Same thing with the wheels. We can design whatever type of look, feel, style, make it rugged, make it aerodynamic, make it sleek, and the AI will help the designer pick the right choices, bring it all together, and create a beautiful image. As you go through that designing and engineering phase, the next part, of course, is manufacturing. It's a huge task to put together a factory. Millions and millions of moving pieces and parts, robots, people, the assembly line. What we've done is help companies like BMW, like Mercedes, put this all into the virtual space using Omniverse. That's our industrial metaverse and digitalization platform. They're able to plan the factory before they even build it, lay it all out, replicate every single piece of the car's moving through the assembly line, the robot's working, the workers grabbing parts off of the carts, assembling the cars. And this gives them the ability to lay out and optimize the factory before they even build it. Huge cost savings, huge time savings. Or if they have an existing factory and they want to switch over to a new model, maybe going from internal combustion to electric, it's very costly to shut one line down and bring up another. So by doing it virtually first, they can optimize that transition and again, reduce the amount of downtime. What we see now is a real production line interspersed with the virtual elements, and the ability now to model every aspect, every bolt, every weld on that car, and be able to then plan for that optimized factory. So doing it in that virtual space beforehand, it can be tuned, it can be optimized, and also the robots are programmed in that virtual world. That software then goes into the real robots and can run in the real factory. So we're using this not only for building the physical cars, but developing the software that goes into cars as well. NVIDIA has been working with hundreds of car makers, truck makers, robo-taxi companies, shuttle companies, on developing automated and autonomous technologies to go into our transportation system. There's a lot of different things we need to account for to make sure that it's safe. Humans, of course, are sometimes drowsy behind the wheel, get distracted, could be intoxicated, right? There's a lot of bad things that happen on our roads. So bringing this automated driver assistance and autonomous technology to market is going to make our roads a lot safer. But the challenge is, how do we make sure that it can handle everything? How do we make sure it's safe and that it's going to drive much better than all of us? And so what we need to do is develop the AI that can handle the uncommon things. And so we'll use AI, and specifically generated AI, to help train the neural networks, the artificial intelligence software, that has to understand the environment. And then we'll use generative AI also in simulating and testing to validate that it all works. So a challenge, of course, is that things that we need to know how to handle don't happen very often. Normally we're driving around and it's just a normal day of traffic. But what we have to be able to do is ensure that that autonomous car can handle the things that almost never happen, that could be very dangerous. So if we're driving around collecting data to train these artificial intelligence agents, and we don't see the things we need to know, we have to come up with a better way. And that's using simulation. So using generative AI, we can create scenarios, we can create scenes that don't commonly exist, and use that as a way through synthetic data generation. We also then create a physically paced world where cars and people and trucks and the environment all interact together. And finally, we use end-to-end simulation. So we actually create synthetic data. We feed that into the computer that's actually in the data center, but ultimately will go inside the car. And so we simulate the camera, we simulate the radar, we simulate the LiDAR, and feed that into the computer. It thinks it's driving on the Autobahn. It doesn't know it's in a rack in a data center, but it's making all the key driving decisions, deciding to brake, accelerate, turn left or turn right, as if it were driving on the road. And so we're able to repeat this over and over in simulation to ensure that the car can handle every situation possible. So for generating the assets, we again have many different ways using these techniques to create different cars, different trucks, different types of vehicles, and then can integrate the kinds of behavior into these vehicles that they would exhibit on the roads. We also use generative AI as part of the training, for example, for signs. Not every sign looks the same, so all we need to do is input an original stop sign, and then using this text-to-image kind of technique, we can create signs as they actually appear in the real world. And then we train it by putting these signs in different lighting conditions, putting them in different environments. Maybe there's some trees that are partially covering up, and all of that data is then used to train the brain on how to recognize a stop sign in any conditions. We can also then change the look and feel of everything in the environment. So again, if we have a rendered scene, a car in a building, we can change the lighting, we can change the season, we can change all aspects of that. So again, the brain learns through this training with a massive amount of data. In some cases, too, we can take video in and then generate new video out. So in this case, we have a drive that we initially did. We're able to now harvest different objects from that and build models of these cars from the video feed. We then create a whole 3D environment based on that drive, and now that one scenario lets us create a massive number of other scenarios to test. We can change the cars, we can change the speed, we can introduce other characters into the scene. We can do things that would be too difficult to actually test in the real world or too dangerous and do it in the virtual world. We can also then adjust the timing, so we can see how the car would handle all different kinds of situations and do this repeatedly over and over so we can test and validate the software and make sure it's safe before it goes in the vehicle. We can also, again, use map data and a lot of generative AI to now create these virtual environments. Otherwise, it's too difficult to do by hand. So the computer is generating the data set that's used to train, and then we use a different data set to actually test that it all works. So here we're actually driving in a model of downtown San Jose, and we're able to test and validate everything. Finally, we've built the cars. We've tested the cars. They're available to sale. Generative AI is part of the marketing and the sales. We can create car configurators that are dynamic, people can interact with. They can put the car in any environment. Ad agencies are taking this technology to create TV commercials or personal videos that are not based on actual camera crews or helicopters flying around, but again, all generative AI. We can also simulate what goes on inside the cockpit and let people take virtual test drives of these cars. WPP, which is the world's largest advertising agency, is working with NVIDIA and several automotive partners to enable these kinds of car configurators. In the past, you had to sit there and actually pre-render all the different frames. But now using a technique and using the universal scene descriptor language, we create these 3D models that come directly out of the CAD data from the designers and can now be used to create the brochures, create the web experiences, to create virtual test drives, and all kinds of other experiences. So you can actually select what kind of environment you want the car to be driving in, and all this is synthetically generated. So if you want to see how your future car looks in your driveway, you'll be able to do that with these techniques. So now again, from the end to end, from the designers, the engineers, the production team, all the way through the developers of autonomous vehicles, and even to retail, we're seeing generative AI change how everybody does their job. It's unifying the whole workflow. A single model of the car from the designer through engineering, production, even retail, helps the automaker streamline all their processes. And again, we're just getting started. It's so exciting to see all the new apps that are coming out, the integration into existing software, and the tools that are available to all of you. You'll be able to do your jobs better. You're not going to be replaced by AI, but you're going to be able to do a better job with AI than somebody who's doing your job without AI. Thank you very much.